NFPA 70, the National Electrical Code, Section 501.4b3 permits the installation of type CMR cables and cable trays within Class 1, Division 2 locations, specifically when these cables are supplying power to equipment that is also permitted in such locations. Let's break down why this installation is permissible and the factors that make it compliant. Firstly, the cable in question is CMR rated. CMR stands for Communication Riser Cable. These cables are specifically designed and tested to resist flame spread and smoke propagation, making them suitable for use in vertical runs in buildings and, in this case, certain hazardous locations. Secondly, a cable is installed in a cable tray with a divider. The presence of a divider within the cable tray is crucial. This divider serves to physically segregate the CMR cable from other cables or potential sources of ignition that might be present in the adjacent compartment of the cable tray. This separation minimizes the risk of flame propagation should an issue arise in one of the compartments. Thirdly, the cable is supplying 24 volts direct current to field flow transmitters. The fact that the cable is carrying a low voltage, specifically 24 volts direct current to power field flow transmitters, is also important. This voltage level falls within the allowable power parameters for equipment that is permitted to operate in Class 1, Division 2 locations. Class 1 locations are those where flammable gases, vapors, or liquids may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 2 indicates that the hazardous materials are not normally present in explosive concentrations but may exist accidentally. NFPA 70 Article 501 provides detailed guidelines for electrical installations in Class 1 hazardous locations. Section 501.4 specifically addresses wiring methods. Section 501.4b deals with wiring methods specifically permitted in Division 2 locations. Key considerations for electrical installations in Class 1, Division 2 areas include minimizing the risk of ignition from electrical equipment. This is achieved through various means, such as using explosion-proof enclosures, intrinsically safe circuits, or other methods that prevent arcs, sparks, or high temperatures from igniting the surrounding atmosphere. Cable trays are recognized as a suitable wiring method in many industrial and commercial applications. When used in hazardous locations, cable trays must be installed and maintained in accordance with the NEC and any other applicable codes or standards. The use of a divider in the cable tray is an additional safety measure. By physically separating the CMR cable from other cables or equipment, the divider helps to prevent the spread of fire or ignition from one compartment to another. Field flow transmitters are instruments used to measure the flow rate of liquids or gases in industrial processes. They are commonly used in chemical plants, refineries, and other facilities where accurate flow measurement is essential. The specific requirements for electrical equipment used in Class 1, Division 2 locations are outlined in NFPA 70 Article 500 and Article 501. These requirements are designed to ensure that electrical equipment does not pose an ignition hazard in the presence of flammable materials. When installing CMR cable in a cable tray in a Class 1, Division 2 area, it is essential to follow all applicable requirements of NFPA 70 and any other relevant codes or standards. This includes ensuring that the cable is properly supported, protected from physical damage, and grounded in accordance with the NEC. The installation must also be inspected and approved by a qualified electrical inspector to ensure that it meets all applicable requirements. In summary, the installation of CMR cable in a cable tray with a divider to supply 24 volts direct current to field flow transmitters in a Class 1, Division 2 area is permitted under NFPA 7501.4b3, provided that all other applicable requirements of the NEC and other relevant codes and standards are met. Always consult the latest edition of NFPA 70 and any other applicable codes or standards for specific requirements and guidance. Additionally, it is recommended to consult with a qualified electrical engineer or inspector to ensure that the installation meets all applicable requirements. It is important to note that other sections of the National Electrical Code may apply depending on the specifics of the installation. For instance, Article 392 covers cable trays and should be consulted for proper installation methods, fill requirements, and support spacing. Article 300 contains general wiring requirements that apply to all electrical installations, including those in hazardous locations. These requirements cover topics such as conductor sizing, overcurrent protection, and grounding. Article 310 provides requirements for conductors for general wiring, including ampacity ratings and insulation types. When selecting conductors for use in hazardous locations, it is important to ensure that they are suitable for the environmental conditions and that they have adequate ampacity for the intended load. Article 500 defines and classifies hazardous locations based on the type of hazardous material present and the likelihood of its presence in explosive concentrations. This article provides essential information for understanding the requirements for electrical equipment and wiring in hazardous locations. Article 501 provides specific requirements for electrical installations in Class 1 hazardous locations. This article covers topics such as wiring methods, equipment enclosures, and bonding and grounding. It is essential to carefully review and comply with all applicable requirements of Article 501 when installing electrical equipment in Class 1 hazardous locations. Proper grounding and bonding are critical for ensuring the safety of electrical installations in hazardous locations. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip over current protective devices and prevent electrical shock hazards. Bonding ensures that all metal parts of the electrical system are electrically connected together, which helps to minimize voltage differences and prevent the accumulation of static electricity. The National Electrical Code provides detailed requirements for grounding and bonding in Article 250. These requirements must be carefully followed to ensure that the electrical system is properly grounded and bonded. Regular inspections and maintenance are essential for ensuring the continued safety of electrical installations in hazardous locations. Inspections should be performed by qualified personnel who are familiar with the requirements of the National Electrical Code and other applicable standards. Maintenance activities should include checking for loose connections, damaged wiring, and other potential hazards. Any deficiencies that are identified during inspections should be promptly corrected. In addition to the requirements of the National Electrical Code, other codes and standards may also apply to electrical installations in hazardous locations. These may include standards published by organizations such as the International Electrotechnical Commission, the Institute of Electrical and Electronics Engineers, and the National Fire Protection Association. It is important to be aware of all applicable codes and standards and to ensure that the electrical installation complies with all requirements. The specific requirements for electrical installations in hazardous locations can vary depending on the type of hazardous material present, the likelihood of its presence in explosive concentrations, and other factors. It is essential to carefully evaluate the specific conditions at each location and to select electrical equipment and wiring methods that are suitable for those conditions. If there is any doubt about the applicable requirements, it is always best to consult with a qualified electrical engineer or inspector. When working with electrical equipment in hazardous locations, it is essential to follow all safety precautions and to use appropriate personal protective equipment. This may include wearing flame-resistant clothing, safety glasses, and gloves. It is also important to be aware of the potential hazards associated with this specific equipment being used and to follow all manufacturers' instructions. By following these guidelines, it is possible to safely and effectively install and maintain electrical equipment in hazardous locations. Always prioritize safety and consult with qualified professionals when necessary. Remember that electrical installations in hazardous locations require specialized knowledge and expertise. It is important to seek professional guidance from qualified electrical engineers, inspectors, and contractors who have experience working in these environments. They can help to ensure that the installation meets all applicable requirements and that it is safe for personnel and the environment. Continued education and training are essential for staying up to date on the latest requirements and best practices for electrical installations in hazardous locations. Attend industry conferences, workshops, and training courses to expand your knowledge and skills. Stay informed about changes to the National Electrical Code and other applicable standards. By continuously learning and improving your expertise, you can help to ensure the safety and reliability of electrical installations in hazardous locations. The selection of appropriate cable glands and fittings is also critical for maintaining the integrity of electrical enclosures in hazardous locations. Cable glands and fittings must be approved for use in a specific hazardous location and must provide a secure and reliable seal to prevent the ingress of flammable gases, vapors, or liquids. The National Electrical Code provides detailed requirements for cable glands and fittings in Article 501. These requirements must be carefully followed to ensure that the electrical enclosure is properly sealed and protected. Surge protection devices are often used to protect sensitive electronic equipment from voltage surges caused by lightning strikes or other electrical disturbances. When installing surge protection devices in hazardous locations, it is important to select devices that are approved for use in those locations and to install them in accordance with the manufacturer's instructions and the National Electrical Code. Surge protection devices can help to prevent damage to electronic equipment and to ensure the continued reliable operation of critical systems. Explosion-proof enclosures are designed to contain an internal explosion without causing an external hazard. These enclosures are commonly used to house electrical equipment in Class 1, Division 1 hazardous locations, where flammable gases, vapors, or liquids are normally present in explosive concentrations. Explosion-proof enclosures must be constructed of robust materials and must be designed to withstand the pressures generated by an internal explosion. The National Electrical Code provides detailed requirements for explosion-proof enclosures in Article 501. Intrinsic safety is a protection technique that limits the energy in electrical circuits to levels that are too low to cause ignition of flammable gases, vapors, or liquids. Intrinsically safe circuits are commonly used in Class 1, Division 1 hazardous locations where the risk of ignition is highest. Intrinsically safe equipment must be designed and certified by a recognized testing laboratory to ensure that it meets the applicable safety standards. The National Electrical Code provides detailed requirements for intrinsically safe equipment in Article 504. When working in hazardous locations, it is important to be aware of the potential for static electricity to accumulate. Static electricity can be generated by the movement of people, equipment, or materials. If static electricity is allowed to discharge in a hazardous atmosphere, it can create a spark that could ignite flammable gases, vapors, or liquids. To prevent static electricity hazards, it is important to ground all metal objects and to use static dissipative materials. The National Electrical Code provides detailed requirements for static electricity control in Article 502. When performing hot work, such as welding or cutting, in hazardous locations, it is important to take special precautions to prevent fires and explosions. Hot work permits should be obtained before starting any hot work activities, and all flammable material should be removed from the area. Fire extinguishers should be readily available, and personnel should be trained in their use. The National Fire Protection Association provides detailed guidelines for hot work safety in NFPA 51B, standard for fire prevention during welding, cutting, and other hot work. When working with flammable liquids, it is important to store them in approved containers and to handle them in a safe manner. Flammable liquids should be stored in well-ventilated areas away from sources of ignition. Spill containment measures should be in place to prevent spills from spreading. The National Fire Protection Association provides detailed guidelines for flammable liquid storage and handling in NFPA 30 Flammable and Combustible Liquids Code. When working with flammable gases, it is important to ensure that the area is well ventilated and that there are no sources of ignition present. Gas detectors should be used to monitor the atmosphere for the presence of flammable gases. If a flammable gas leak is detected, the area should be evacuated immediately. The National Fire Protection Association provides detailed guidelines for flammable gas safety in NFPA 54, National Fuel Gas Code. In addition to the requirements of the National Electrical Code and other applicable standards, it is important to follow the recommendations of the equipment manufacturers. The manufacturers of electrical equipment used in hazardous locations provide detailed instructions for installation, operation, and maintenance. Following these instructions is essential for ensuring the safe and reliable operation of the equipment. It's always best practice to consult with a qualified professional to determine if this is a suitable situation. Firstly, review the product labeling and manufacturer's instructions to ensure the cable is rated and suitable for the intended use in a Class 1 Division 2 location. Secondly, verify that the cable is adequately supported and protected from physical damage along its entire length within the cable tray. Thirdly, ensure the cable tray is properly grounded and bonded to maintain electrical continuity and minimize the risk of static discharge. Fourthly, inspect the cable and its connections regularly for any signs of damage or deterioration and replace any damaged components promptly. Fifthly, confirm that the field flow transmitters being powered by the cable are also approved and suitable for use in a Class 1 Division 2 location. Sixthly, ensure that the cable tray is properly identified with appropriate signage indicating the presence of electrical cables and the hazardous location classification. Seventhly, maintain a clear and unobstructed path to the cable tray for inspection and maintenance purposes. Eighthly, provide adequate training to personnel who will be working on or near the cable tray, covering the hazards associated with Class 1 Division 2 locations and the proper procedures for safe work practices. Ninthly, establish a regular inspection and maintenance schedule for the cable tray and its components, documenting all inspections and maintenance activities. Tenthly, keep records of all certifications, approvals, and inspections related to the cable tray and its installation, and make them readily available for review by regulatory authorities. Remember that proper installation, inspection, and maintenance are crucial for ensuring the safety and reliability of electrical systems in hazardous locations.